Good afternoon, team.
Hello.
How's your day going?
Oh, well, you know, um, it exists.
Uh-huh.
Right side of the dirt. How's your day going? Hi,
Hello.
Will.
About the same. Hard to be motivated when there's nobody here with the weather.
Oh, yeah, I'm not there either. I went to campus and I figured that was my duty for the day. I don't mind the snow. I like it. I was pleasantly surprised to see it.
I did not enjoy driving back to Fort Collins in it.
Where were you, Will?
I was in Denver. Um, so um, I was working at the office yesterday, and then I stayed with friends in Castle Rock, and
Mm.
then I went by the house there and picked up our monitors, and then Kate got back like right at 12.
And were the roads bad?
They were they were just slushy. So
Hmm.
it's almost like there was really nothing like plows could be doing at the time, you know? I didn't like, having to get the snow off of my, because there's quite a bit that fell overnight or whatever in the morning.
Yeah.
But
It's
it was definitely slow going. I mean, I was doing probably 45, 50 from Castle Rock to where the 322 house was.
that's a ways to do 45.
Yeah. So, and it was pretty slow. No one was really driving crazy, so I was fine with it being slow. I was this morning. I was like, I am in no hurry to get anywhere I need to go. I just want to get there.
Hmm. Sounds like a good plan. How's everyone? I know Marilee won't be available. Poor Marilee. She's demonstrating why one does not want to be a department head. Um, oh, and Erica, I don't remember if Erica's out today.
I don't think she's here because she told me she was in Prague a few days ago.
Oh, right. She's on that trip. Yeah, yeah. Okay. Um, so I wanted to check about next week. We didn't schedule a topic yet, and I think a lot of people are out because it's the beginning of spring break. Um, I mean, should we just cancel it or do people have a proposal? Is there anything people want to talk about? I will be around, so I'm not trying to get rid of the meeting, but I also feel like it's more more useful when people can talk things out. Okay, so one, is there any that was a very vague question. No wonder nobody's answering. Um, are there does anyone want to use that meeting for something? Because I don't have ideas.
I don't have anything, and I would not be opposed to getting an hour back next
Hmm.
week.
Yeah, I don't think anyone here would complain about getting an hour back.
Yeah, I think about the only thing I would say is if the thing with the circuit board gets to a point where tech team needs to do something, or Chris and I need to do something, we could use that time, but I don't have a feeling of a need for the whole group. So that's what we could use the time for if need be.
Yeah, and we do have a tech team meeting the day before, right?
Right, so
So we can
hopefully
make
you
a
wouldn't
call
need
at
it.
that meeting about if we want to use that time.
Yeah.
Okay. Okay. So I'm just, yeah, I'm just going to say that I'll take the Sapphires meeting off the calendar and I won't put anything else there. And then if we need to do something, we can do something. Cool. Kristen, you wanted to talk about,
Yes. So we were talking about a while ago doing an in-person meeting. Looking at the calendar, I was looking at May 8th, but it is last day of classes. So it was kind of one of those, would people want to do it that day, or is that I need to look for other, because the next week is commencement. And yeah, just, and if anybody has any ideas on what we can do. Previously, we've done kind of workshop-y type things. We could kind of think about a team building thing as opposed to workshop-y, but there's not a huge like thing that's in my head that's like, we have to be doing this. So yeah, that's pretty much all I had. But if May 8th works, and then we can figure out what we can do.
so maybe just
That
speak up, put in the chat if it doesn't work. And then also I had a thought that we generated several ideas in the what's next.
That's what
So
you
one of those could be fodder. I'm not hearing any complaints.
Nope.
Okay. So I have a small presentation today. I'm a little embarrassed because I canceled a meeting a couple of weeks ago because I was like, I really want to have all this stuff done so I can show it to everybody. And it is still not done, but I decided I could not cancel again. That would not be okay. And I think there's plenty to talk about. So I'm going to try to share my screen in a way that doesn't prevent me from seeing people, which it usually does. Yeah, okay, I can see. Can you see? And I'm gonna just leave it in large, but not presentation mode, because I think that's what blocks people out. Okay, so um, I have been working on connecting the delta pressure measurements with predicted flows into a house, and therefore what particulate matter we should expect to see. And I'm going to do a little bit of review, something I've talked about before, to explain why I think this is important, and then show you using the Epic Home data what I think, or what I'm seeing and what I'm concerned about. Overall, I think my role in this, in part, is to help us conduct the field study in a way that we can distinguish whether the interventions are effective. And of course, people have a lot to do with the interventions, but there's going to be interpretation of data at the end. So the first few slides will be review from what I presented last August. So the goal of Sapphires is to quantify the effectiveness of each intervention compared with the untreated state. And of course, there's also the variable of whether it's automated or notified. So the two interventions are never in the same house. So that just means that we are going to get, in each test house, we'll get an effectiveness for one intervention. And then there's a lot of underlying variability. And so what I did in my presentation last summer is I walked through the causes of variability and how we were going to address them. But in general, we're defining effectiveness as a fractional reduction in average indoor concentration compared to what it would have been without the intervention. And that means we need to know the average or the indoor concentration without the intervention. And that entails some simulation or prediction. Oh, sorry, that's duplicate. I squished it on the other slide. Okay. There is variability in infiltration and air exchange. And so I've been using this new term, outdoors found indoors, or OFI, to mean the outdoor pollution that is found indoors. And one of the interesting and exciting things about this project, I think, is that it's a step on the way to separating OFI and indoor generated pollution with diagnostics, which would imply that we can then manage them separately. And they're going to have probably different tools, but up until now, it's been like, well, there's pollution indoors. Maybe it comes from outdoors. Maybe it comes from indoors. If it's spiky, probably indoors. We don't really know. And so the possibility that we can identify and prevent outdoors found indoors pollution is, I believe, what we're working on. And so the plan was to measure pressures or measure some diagnostic thing. And sorry, I just lost the. Okay, and then predict the expected outdoor found indoor concentrations over the entire outdoor pollution event, and then compare those with what we actually did measure to see the effectiveness of interventions. So is everyone cool with that? Have I lost anyone? Okay, so here's the big issue. In order to evaluate the effect of the interventions on OFI, we need to have some. There has to be some outdoor air found indoors, because otherwise there's no point. If there's none, can we even do the field experiment? Will we be able to detect the influence of an intervention? My answer is probably not. And then so finding outdoors found indoors requires, this is assuming that air is the transport mode. It requires three things. One, measurable outdoor pollution. So that's why we've been doing phase 1 on homes to see if they have pollution outdoors. 2, cracks or leaks in the home. All homes have this, and we determine it with the blower door test. And 3, a pressure difference between the indoors and the outdoors to push the pollution in. And those are in the natural case where there's no mechanical intervention, those are driven by weather conditions. Okay, so I'm going to show you first an example of a prediction, outdoor air found in. So again, these are going to be our EPIC homes that we did a couple years ago. We measured outdoors, we measured indoors, and now in the yellow line, you have the prediction of outdoors found indoors. And I'll tell you how I do that on the next slide. But a couple things to notice, just as Christian pointed out in the very beginning, there's a little bit of a lag between the outdoors and the indoors. So that allows you a little time to anticipate what you're going to do. In my understanding, Christian's algorithm is sensing a leading edge, and then you say, hey, it's not indoors yet. We have some time to act on it. Okay, so how is that done? From Dom's work, this is what we're doing right now. From Dom showed by comparing measured stack pressures with predictions from temperature, that those predictions were actually pretty good. We almost don't even need to measure the stack pressure. And so that prediction from temperature is used in these estimates. Then the wind pressure prediction is less certain, but also less important. So I'm taking the measured wind pressures we have, using them in some kind of hand wavy exchange estimates. They don't contribute a lot to the exchange, and I will show you that at the very end, but that's where we are now. And so all of our retrospective data, with a couple of exceptions, now has this ability to estimate flow every minute using the predicted stack pressure, the wind pressure, the blower door measurement is all embedded in the input files, and then you get an outcomes for your analysis, that outdoor found indoor with the simple finite difference equation. You can do it more in a more complex way, but it's probably not worth it given that we're predicting at every minute. So that is where all that comes from. It's got the pressures, the blower door, etc. in. So a couple of points before I get to my big questions. One, obviously the accuracy of the outdoor monitor is critical, right? So this outdoor monitor at 229, I don't think was any good at all, because look how high it is. And it's that could have been a pollution event. But we have had times, at least one time in the phase 1 measurements, where we said the outdoor is probably bad and we should test them. And so this is a reason why I am now so uptight about the intercomparisons, at least before we go out to the field. Because we need that ability to have an OFI prediction. The outdoor monitor is important. The indoor monitors are important too. But if we don't have that, we have nothing to assess the effectiveness of the intervention. So just a point. And then it looks like we need to account for penetration factor or deposition within the house. So again, blue is outdoor. The red is the indoor measurement. They look pretty good, or the indoor and the OFI compare pretty well in terms of their time dependence, but not in terms of their magnitude. And that, I would guess, is likely what's called penetration factor, which is how much of the outdoor air makes it through the building shell. Maybe some deposition. The reason I canceled last time is I've been intending to build those into the code, and they're not there. They're still not there. However, I believe that since we're doing baseline at the beginning and end of the study, they can be sort of quasi-calibrated. Okay, so that's a point. And it's really nice. You can see the outdoor does not look anything or very much like the indoor time series. But just predicting from the indoor combined with the predicted infiltration, it doesn't look too bad in terms of time dependence outdoors and indoors. Or yeah, indoors predicted and indoors measured. Does that make sense? Okay, so some slight hope. And then another aside, I don't know what these indoor oscillations are. I don't know what would cause an indoor particulate matter measurement to oscillate like that. Just another reason to make sure we know what those instruments are measuring before we send them out to the field. So we did the particulate matter measurements at Epic Homes. They felt less important at the time. And we just sent the Omnis out, took the measurements, and now that I'm trying to explain them, there's all kinds of things that I wish we had done differently or measured better. The good side is we have not yet sent them out to our phase 2 homes, so we have a chance to bring those in. Paul, I don't know. It could be furnace, right? Paul asks, what's the time scale of the oscillations? I don't know. I can look into that.
Yeah, that furnace is my first thought, but it depends on that time scale whether that's plausible.
Yeah, but what would it be drawing them in from outside?
So there's a number of possibilities. One is that. One is that they haven't changed the filter and it's resuspending particles off the filter. That happens.
Weird, really?
Yeah, that absolutely can
2.5?
happen
Yeah, I
with
guess.
with filters that
Huh.
haven't been changed in a while. So Yeah, I mean duct leakage that's pulling stuff in from
Sure.
somewhere, or imbalances between a place that generates particles and places that don't, that get triggered with like not having good return air pathways. But um, so there are a number of ways that that can manifest. But if these were like every 2 hours, it wouldn't be that.
Yeah, they're not. I mean, you can see this is 24 hours here.
Yeah,
So,
yeah.
so I have only a couple more slides, but I do have MATLAB up so I can pull up data and look at it. This is probably not the thing we most want to investigate here right now. But I was expecting that people would have questions that I did not anticipate. So I'm ready to just share screen and look at the MATLAB time series if people want. Okay, so now I'm going to get to the question that has me worried. What happens when there is no driving force for air exchange, which is mostly temperature difference? So the previous graphs were in December, and this one is in kind of a shoulder season at the end of September. Outdoor events don't get observed inside. You can see this tiny little blip. So the average air change rate over this entire period was 0.07 air changes predicted. And what we expect to see is something more in the 0.2, 0.3 range. They can get higher as houses get leakier, and that would indicate a faster exchange between indoors and outdoors. Some of the houses or some of the things we were looking at previously, I think those air change rates were around 0.4 over the period. And that is a function of three things. One, how leaky the house is. Two, the temperature difference between inside and outside. And three, how large the house is. Because a bigger house needs more airflow to ventilate it. So, my fear is that we're now headed into sort of summer or low temperature difference territory for doing the field experiment. And then we're going to see OFI that's going to be like this, and we're not really going to have any events to compare. So this is what has me freaked out. And if I'm hollering about time, this is why, but we've already missed our best window. I want to show you a couple more things. This is that same period. But this is the magnitude of infiltration flow. So it's like 20 CFM, most of it stack. You do still have a diurnal variation in that. Oh, this should not be marked outdoor indoor. I'm sorry. This is stack and wind. Bad labeling. And so you see the wind picking up kind of during the day, and so offering some, but these are small numbers. The tech team has been talking about trying to provide 200 cubic feet per minute. I realize that's a maximum. That's like kind of the top you've been shooting for the fan to be able to deliver. But that was envisioned because we were expecting the actual infiltration flow, I would guess, to be something more like what you see over here in the winter, right? So 70, 80, and then there's that site over more days, it's like 20. So it's like a quarter of the driving force and unlikely to bring in outdoor air when we have it. Or when we have pollution. So I think the overall impression is that you get very low air change rates, very low bringing in outdoor air, and then even if we do have pollution events, we might not see them, and that will make it difficult to test the effectiveness of the intervention. Okay, so that is all the presentation I have, and then I will open it up to discussion, data requests, complaints and then I hope I'm wrong, right? I hope that everything's fine.
So, this last thing you were showing, and we talked about that at the tech team meeting yesterday afternoon. And as you say, it depends on multiple things. It depends on the size of the house, the airtightness of the house, and the temperature difference. And so, um, I'm wondering whether it has been done, whether it would be, if it hasn't been done, whether it would be plausible to kind of look at, any home that was done where there were common temperature differences similar to what you were just showing, and what kind of predicted airflows do you have, and how, and looking at those other factors also, because yeah, if you have tight houses with no stack effect, then yeah, it makes sense. You're not going to have much infiltration. And so what are we doing? But it might also lead us to bring in some additional selection criteria that, if we're going to be measuring in the more of a shoulder season, we want to have a house that's at least this leaky kind of thing.
And I think so I was showing you that one where it was pretty much flat. I was showing you the worst case. Like
Yeah.
it's a big house that isn't very leaky. Um and and so it yes, Paul, I think we can consider that, but we do have to consider it. We can't just take any house and hope that it works out. We do have the possibility, I think, to not see any events indoors, especially in shoulder seasons, if we are not careful.
Yeah. No, that's really, really important and valuable to see just how bad it can get. Because, as I mentioned in the meeting yesterday, I figure a place like Colorado, we have 30 to 40-degree swings in temperature between low and high every day.
But
And
not always, right?
well,
Not
most
always.
days. If we're in a house for 2 weeks in each segment, it's probably not going to be narrow temperature bands the entire 2 weeks. But seeing how bad it can get, that I can't deny that. And so that does make me think that maybe a little analysis session would be good to kind of look through some of the houses and see what we might be able to glean in terms of additional screening criteria. And I think that would be fun to do with whoever was interested, if that is a reasonable thing to do.
So I have the data up. So every house of the Epic homes has an OFI prediction. Except for one where the outdoor air was not measured. And I have not done that with our phase one houses yet. To some extent, the principles are you don't need to look at every single house to gather information because it's just a prediction. We know the terms in the equations. And so Paul, you say like, well, it's not going to be that way all the time. Yes, that is true. And let's recognize that it's just that the more um non-usable days you have, the likelihood that the number of events drops,
Hmm.
right? So you already don't always have pollution. Um and so you're just yeah, you might still get some events, but you could also be decreasing your chances of seeing, kind of blowing our power calculations because we calculated a certain number of events
Hmm.
that we wanted to see.
Yeah. Yeah. I feel like you show that we can't just ignore this effect and I also feel like we ought to be able to quantify things in a way that allows us to be more selective to make sure that even when there might not be a big temperature difference, we're not going to have this problem.
Curious what other people think. Or what, like, even if you don't have a thought right now, like what comes to your mind?
I guess kind of from the other side of looking at this with like, even if we had gotten this into homes this winter, I feel like this winter has been so anomalous with like our average temperature in February is what, 55 degrees Fahrenheit? Like that's insane. And so we would have seen something just like what we saw in October. And looking at like this summer, by all indications, like El Nino's coming back, it's supposed to be incredibly hot. And so we might see some of those temperature differences during the day that might drive, we might see something that would be more similar to winter in terms of those delta T's. And so, but it's just so uncertain. Like if we get a strong El Nino this year and over the summer, like maybe next winter will be even hotter. And so it's just like we don't know. And so I wonder if this summer might not be that bad just because it's so atypical. And because like the weather is just so catawampus that we might get these wild temperature swings during the day, between day and night.
Mm-hmm. That's a good point. We may
Did
have
you
an
use the word
opportunity.
cattywampus?
He
I
did.
did.
That is
Yeah.
one of the all-time best words in the English language.
Okay, but I don't want to be living in it, but we are. Yeah, you have a good point, Danny. I would point out both that we were less good at predicting stack pressures under summer conditions, but this might give us an opportunity to try. And also I don't think we were way off. So another concern about doing the field project in shoulder seasons is that when the weather is moderate, people may like to open their windows. And so then it's not that they shouldn't open their windows, but that is not a time when we can test the intervention. So yeah, maybe they shouldn't open their windows.
Yeah, so one thought I've had about that is that's true. But we also know that like the absolute worst of the Cameron Peak fire was around Labor Day. And that's a shoulder season too.
Mhm.
And so it may well be that, yeah, people like to open their windows in the shoulder seasons, but if it's a wildfire that's causing the outdoor air to be bad, they may close their windows anyway because the outdoor air is so horrible. And one of the advantages we have is when it is relatively mild, if that would be getting in, we don't need to generate a lot of flow to positively pressurize the house. And one of the advantages, like if we're using the window units that Christian is working on, and it's just putting in untempered outside air, you'd rather do that in the shoulder seasons than in the winter.
Yes, that's an advantage. I
Yeah.
agree.
So it's
I've
not all
been concerned about the conditioning of the air.
yeah.
Tammy, a question that comes to my mind is the power based on a number of events?
Yes, it was.
So if what I keep hearing is more and more reasons why a real world scenario isn't a great fit for testing the performance of the intervention, would we be able to minimize the number of homes over which then we could have some control? Maybe they're friendly homes where we could say, I know it's uncomfortable to open your windows, but please don't. Like, it seems like there's enough
Mm.
risks that are outside of our control if what we're enrolling are just, sort of typical human subjects that if the number that we care about is number of events and not number of homes, then spending more time in a few homes over which we have more control might increase that number.
It's an interesting thought. What do other people think about that?
One thing I like about the longer piece is I think we're going to have some real big changes in the first couple days, weeks, because this is such a new thing. Just giving enough time for people to settle in and actually see how they're using it from the interface tracking. So a couple pieces, I guess, like more friendly homes where we prescribe things. I think we're going to get less natural behavior. So we might lose a little bit of like, how does somebody actually use this? Fewer homes, but if we could be in there for longer times,
So
potentially.
it is sorry, you were not done.
No, I think I'm just repeating the same thing at that point. Like, I just feel like the first couple days, well, something I've been worried about is I think the first couple days are going to be lost, wasted data from the manual control side of things, just because this is a new gadget in their home, like enough settle in time to see how it performs.
So that was actually built in. Marilee had estimated, or she had some literature on novelty effect. And that is part of why the periods are as long as they are, is that you would get past that.
Yeah, I know we tried to build it in. I just think I am maybe more skeptical about how, like, based on how many times we get questions for clarification in the first couple of weeks of
Mhm.
studies, the longer we can go, and if that means fewer homes,
Yeah.
the
I
longer.
think it was 2 weeks that she said. But yeah, so are you advocating for even longer than the 16 weeks?
I'm just kind of like laying out the different. I think Ellison's point of fewer homes where we have friendlier behavior and maybe we can tell people things. I really like that in some
Mhm. Mhm.
ways. I'm just trying to balance that with if we're telling people to do more things, what does that mean for the like settle in period? So I don't think I'm advocating for anything. Just
Mhm.
trying to figure out the more we prescribe, the less natural it is. The less natural it is, probably the longer we have to do things.
So I'm trying to remember. Yeah, I got to go back and look at the power calculation. Um, but I think certainly some of our thoughts about the field study are being revisited now that we are actually experiencing this. We're experiencing what happened. So one of the thoughts was just confidence, and not confidence as in confidence intervals, but confidence in that if you do only one home, then you could attribute what you learned to a lack of variation. And so I think we wanted to go across multiple homes, just acknowledging that homes are very different. And I honestly do not remember at this time how those considerations played into the choice of sample size. I can go back and try to recreate what I was thinking. But so I think it's an interesting point, Ellison. I think, or considering a longer study, we've already said these homes are not going to be done at the same time, no matter what we do. So we could have them be longer, or we could say, if, okay, you're on vacation for 2 weeks, we'll just leave it in for 18 weeks. And then just not count those 2 weeks that you're gone. So I think we've created some or allowed some flexibility. Like my original idea of these 16 homes all experiencing the exact same conditions in the same location is like not gonna happen. And so we're accounting for that. So it's an interesting thought to just like let it go as long as need be to get the number of events, or to just let it go for a long time.
I'm also going to toss out one other that I say without fully thinking this through, so it's super dangerous in a team setting. I
So you
wonder
want me to
what.
turn the recording off?
No, no. More is like that might be a stupid idea, and I come to that conclusion as I'm saying it. I do wonder as well. So we have lots of interrelated, but not necessarily directly tied together parts of this study. So the idea that's coming to mind that I'm trying to like mentally work around on the fly is, do we actually need all parts for a given home at the same time, or can we actually answer some of the questions quasi independently with things staggering in and out? So, for example, people's desire for information, does that require outside infiltration, right? I think we could make a case that
Hmm.
we get lots of the same information purely from indoor events, and we see there's tons and tons of
Hmm.
indoor events. If we're testing the efficacy in some ways based on the idea of how much it's needed and how well do we think it would work, well, if we knew how that home behaved, which is kind of what you just showed here, can we answer some of these questions more modeling based? So we go into a home, we characterize it, we gather some information based on how technology works from an efficacy standpoint, and we do more modeling on how it would have happened or what impact it could have had, similar to the Paul analysis from 6 months ago. So that's why I said it was dangerous to bring it up without fully thinking. I just wonder if we can bolster some of our study by thinking beyond the constraints of all things have to happen at the same time during the intervention for a given home.
I think to some extent, some of that has happened already. Like we thought we were going to have the people response and the physical response all at the same time. Since then we've said, 16 or 20 homes is not statistically significant anyway, so we ought to think about spin-off studies where we examine people's responses to more in greater numbers and to simpler things. The modeling, yeah, maybe we should just have a data party, because I guess my thought had been to do both and have the field experiment be confirmatory, because I keep seeing things that I am surprised about.
Oh yeah, I
Um,
100% agree. I was just thinking like the time,
yeah.
maybe we can do longer deployments on some of these for the measures that we need for what we think
Mhm.
infiltration would have been. That's a pretty unobtrusive, non-obtrusive thing to leave in somebody's home for a
Mhm.
longer period of time than the intervention
Oh, yeah, that's
technology.
an interesting idea. Yeah.
So we get smaller snapshots to say, hey, we're going to validate during this sub period, but actually
Yeah.
collect the data to support longer modeling for a much longer period.
Yeah. Yeah. So I think it's a thing we're doing in other ways, and we might think about how to apply it in the field study. Like the work that Danny is doing, where we're trying to attribute infiltration to stack and wind, we're kind of calibrating on the epic homes, but then we want to do an annual evaluation of what the home would do all year, for example. So we're already doing some of that, and maybe we should. I'm open to redesign of the field experiment, redesign, um, to achieve those same goals. And so I think I'm using the 20 homes, 16 weeks for as a container because it's what we said, but it's totally okay for people to say, I think you should do my home for all year or something. In fact, my home has been measured for a long time. So part of why I'm bringing this issue forward is so we can think about it as we haven't started the field experiment yet, right? And I don't want us to go blindly doing what we said we were going to do in the proposal, get to the end and then go, oops, no events or no airflow.
Now, so one of the things that we're screening for though, right, is that there are things going on. So we are avoiding homes for which there are no events.
Correct.
So at some level, we are at least already screening, trying to design in that there will be some number of events.
Right.
And also at some level, if one outdoor event counts as six, if it affects six houses that are being instrumented at the same time, it's six separate events because it's six separate houses.
Correct. That was the, yeah.
Then that would argue at some level, if we can hit when there's outdoor events, being in as many homes as possible gets us the number of events we want sooner.
This is true. Yeah, and that was actually the original design. I tried to this is all slipping, but I tried to design it for winter and for inversions because I knew the one way to guarantee that there would not be a wildfire is to design our study to capture wildfire events.
Yeah.
Yeah, so I'm not proposing a change as such, but I think there's been a lot of focus on developing the tech, making the tech work. I feel responsible for being able to tell you if the tech has worked, and this is part of it. And what people have done in the past is they've measured average concentrations with and without an intervention, which of course is never at the same time. What we're doing that I think is supposedly better is some amount of prediction or counterfactual of what it would have been there anyway. But then it requires that we're able to estimate that. And that it would exist, right? It has to exist. Okay, I don't have anything else. Anyone have final thoughts? Okay, well, let me know if you think of anything, and thanks for listening. Have a good weekend, folks.
Have a great weekend, everyone.